Good morning, students. This is Murthy, sir. Today, you will learn an important topic in organic chemistry, the functional groups. In organic chemistry, functional groups are specific groups of atoms within molecules that are responsible for the characteristic chemical reactions of those molecules. The same functional group will undergo the same or similar chemical reactions regardless of the size of the molecule it is a part of. This table shows the important functional groups. The general formula for alkyl halides is ORX, where OR is alkyl group and X is halogen. Haloalkane or alkyl halides are the compounds which have the general formula ORX, where OR is an alkyl or substituted alkyl group and X is a halogen, that is fluorine, chlorine, bromine or iodine. Haloalkanes have been known for centuries. Chloroethane was produced in the 15th century. In this table, you can see some examples of haloalkanes or alkyl halides. Bromomethane, iodomethane, difluoromethane, dichloromethane. The general formula of alcohols is OR-OH, where OR is alkyl group and OH is hydroxyl group. Alcohol, any of a class of organic compounds characterized by one or more hydroxyl groups attached to a carbon atom of an alkyl group. Here you can see the chemical structure of ethyl alcohol and also the ball and stick model of ethyl alcohol. The four most common alcohols, which are also the simplest, are methanol CH3OH, ethanol C2H5OH, propanol C3H7OH, and butanol C4H9OH. This picture shows the ball and stick structural model of butanol. Now let us see what are carbonyl compounds. The compounds containing a carbonyl group C double bond O are called carbonyl compounds. The carbonyl group is probably the most important functional group in organic chemistry. These compounds are an integral part of organic chemistry and their primary members are aldehydes, ketones and carboxylic acids. Here you can clearly observe aldehydes and ketones, they have similar molecular formula, but they have different structures, which results in different properties. The general formula of aldehydes is OR-CHO. According to IUPAC nomenclature, the names of aldehydes they end with suffix AL. A compound containing a functional group with the structure CHO consisting of a carbonyl center with the carbon atom also bonded to hydrogen and to any generic alkyl or side chain alkyl group. These compounds are called aldehydes and the general formula is OR-CHO. Here you can see the chemical structures of formaldehyde and acetaldehyde. Their IUPAC names are methanol and ethanol. The chemical formula of formaldehyde is HCHO and acetaldehyde is CH3CHO. The general formula of ketones is RCOR, in which the carbonyl functional group is attached to two alkyl groups. Functional group with the structure RCOR, where R can be a variety of carbon-containing substituents. Ketones contain a carbonyl group. The simplest ketone is acetone, CH3COCH3. It is also called dimethyl ketone. Here you can see the ball and stick structural model of acetone or dimethyl ketone. Here you can see the structures of acetone and acetophenone. This is the ball and stick structural model of acetophenone. In this organic compound, a ring structure seen is benzene ring. The general formula of carboxylic acid says RCOOH, where R is alkyl group and COOH is carboxyl group. Carboxylic acid, any of a class of organic compounds in which a carbon atom is bonded to an oxygen atom by a double bond and to a hydroxyl group by a single bond. The carboxyl group is so named because of the carbonyl group and hydroxyl group. This is the ball and stick structural model of acetic acid or ethanoic acid. 5 to 10% of acetic acid is present in vinegar, which is used as food preservative. These are the chemical structures of methanoic acid and ethanoic acid. They are commonly called formic acid and acetic acid. Formic acid is present in the sting of honeybees and red ants. The general formula of esters is RCOOR. Esters are derivatives of carboxylic acids. Carboxylic acid esters. The formula is RCOOR, are commonly prepared by reaction of carboxylic acids and alcohols in the presence of hydrochloric acid or sulfuric acid. This chemical process is called esterification. In the reaction, the hydroxyl group of the carboxylic acid is replaced by the alkoxy group of the alcohol. Here you can observe the formulae, common names and IUPAC names of some esters: methyl ethanoate, ethyl ethanoate, ethyl propanoate. This is the ball and stick structural model of methyl ethanoate. Its common name is methyl acetate. The general formula of ethers is ROR. Ethers are a class of organic compounds that contain an ether group, an oxygen atom connected to two alkyl or aryl groups. They have the general formula ROR. Here you can see the chemical structures of dimethyl ether and diethyl ether. Their IUPAC names are methoxymethane and ethoxyethane. The general formula of amines is RNH2, where R is alkyl group and NH2 is amino group which is derived from ammonia, NH3. Amines are one of the most important classes of organic compounds which can be derived when we replace one or more hydrogen atoms of ammonia with an alkyl group. Primary amines are formed when one of the hydrogen atoms of the ammonia molecule is replaced by an alkyl or aryl group. Examples are methylamine CH3NH2, aniline C6H5 and H2. This is the ball and stick structural model of methylamine.